Today we will discuss the echelon form of a matrix. The echelon form may be a row echelon and column echelon form. So first of all we will discuss the row echelon form of a matrix and then column echelon form. A matrix of order m by n is said to be in row echelon form if first point is the entries in a row appear to the right of first non-zero entry. So this is the example of row echelon form. Here the first point is the entries in a row appear to the right of first non-zero entry. This is first non-zero entry. So all other entries appear to the right. This is first non-zero entry in this row, right? And you can see there is no uh, column in right hand side, so this will stop here. Second point is the number of zeros preceding the first non-zero element in ith row is less than that of such zeros in I plus 1th row. Suppose this is ith row and this is I plus 1th row. So number of zeros preceding the non-zero entry. Here are two zeros and in this case here are three zeros. So in I plus 1th row the number of zeros are more than number of zeros in ith row. Okay. Third point is all zeros that consist entirely of zeros lie at the bottom of the matrix. So this row consists of all zero elements. So this is at the bottom. This is another example 1063 and this. Okay, in this case also entries appear to the right of non-zero entry. Okay, and number of zeros preceding non-zero entries. In this case there is no zero. In this case there are two zeros. So second point is satisfied. And third point, if there are zero rows, if there are rows that are consisting of all zeros, so they are taken at bottom. Okay. So this is row echelon matrix, and in this row echelon matrix, in case of square matrix, the row echelon form is an upper triangular matrix. So you can see from here, this is upper triangular matrix. From here also upper triangular matrix, and these are zero rows. Okay, we may take some other examples also. One, three, four, 0, 2, 6, 0, 0, 3. So from this I want to clear that it is not required, please note that it is not required that first non-zero entry or leading entry should be 1. No, that is not required. That may be other numeric than 1. Okay, so this is also upper triangular matrix. This is row echelon form. Now column echelon form. In column echelon form, just I am going to replace row by column. Words, in words there is column, and if I replace this row by column, then we will see what will be effect on this definition. Okay, the entries in a column everywhere just replace row by column appears to the right. So in place of right, we'll say here bottom column bottom of first non-zero entry. The number of zeros preceding the first non-zero element in ith row. So in place of ith row, it should be ith column. Ith column. Okay. All columns that consist entirely of zeros lie at the bottom. In place of bottom, I will write down here right. Right. Matrix. So we will take one example. Suppose this is 1, 5, 3, 4. Okay. It is 0, 0, 0. 5, 1, 0, 0. 2, 3, 0, 0, 0. Okay. And 4, 2, 1, 0. Okay. So uh, first point is the entries in a column appear to the bottom of first non-zero entry. So this is first non-zero entries. So entries lies bottom. Okay. First non-zero entry in this column. Entries are below this. Okay. And in this first non-zero. Okay. And this is not necessarily that here should be other element than 0. No, there may be 0 in row or in column. After first non-zero entry, there may be some 0. That may include some 0. So no problem is there. Okay, this was one example, and some other example. 1 minus 1, 1, 1, 1, 1, 1, 0, 1, 2, 2, 0, 1, 2, 2, 0, 0, 0, 0, 0, 0, 0, 0, 0. So this is third point, all the zeros. Okay, all the zeros appear to the right if the column consists of all zeros. So these all are zeros, these are to the right. Okay, and this column matrix is lower triangular matrix. This is lower triangular matrix. Okay, you can see from here this is lower triangular matrix. Okay, now we'll take one example, how to reduce a matrix in raw echelon form. Reduce the matrix to row echelon form. Row echelon form. So matrix A equal to 0 1 2 0 3. First row is 0 1 2 0 3. Second row is 2 4 8 2 4. 2 4 8 2 4. Third row is 1 2 4 2 2. 1 2 4 2 2. And last is 1 3 6 1 5. 1 3 6 1 5. So we will apply the row operations, row transformations to reduce it to row echelon form. If we want to reduce any matrix to column echelon form, then we have to apply the column transformation, okay, or column operations. So in this case, first of all, interchange R1 and R2 so that this 0 come here. We will interchange these rows. R1, R2. So this will be equivalent to 2 4 8 2 4 0 1 2 0 3. We have to satisfy the 3 points from the definition of row echelon form. 1 2 4 2 2 1 3 6 1 5. Okay, and then on this matrix applying R1, so we will divide this row by 2. So applying R1 1 by 2 R1. Okay, so we are going to divide this row by 2. So we get, I am writing down here, 1 2 4 1 2 0 1 2 0 3 1 2 4 2 2 1 3 6 1 5. Okay, now we want here at least 2 zeros in this row. Okay, and if there are at least 2 0, then in this row there must be at least 3 0. If there are 3 0 before non-zero entry, then here must be 4 zeros. Okay, so applying R3 minus R1, R3 minus R1, and R4 minus R1. R3 minus R1 and R4 minus R1. So first two rows are 1 2 4 1 2 0 1 2 0 3. Now R3 minus R1. So this will be 0. This will be 0. 4 minus 4 0. 2 minus 1 1. 2 minus 2 0. Okay. Now R4 minus R1. We are applying this operation as R4. 1 minus 1 0. 3 minus 2 1. 6 minus 4 2. 1 minus 1 0. 5 minus 2 3. 1 2 0 3. Now applying at R4 minus R2. Now if we subtract R2 from this, so these two will be 0. All these elements will be 0. Okay. So applying R4 R4 minus R2. So we get, I'm writing this matrix here. No, because this will not come in this field of view of this camera. So I want to write it here. We get 1 2 4 1 2 0 1 2 0 3 0 0 0 1 0, and this R4 minus R2. So 0 1 minus 1 0, 2 minus 2 0, here is 0, and 3 minus 3 0. So we can see that this is row echelon form. Okay, all the entries are on the right to this non-zero entry. Okay, here is 0. So that is not a requirement that here should be non-zero entry. There may be 0 also. So this is third point. If there is a row which is consisting of all zeros, so that must be at the bottom. Okay, and this is upper triangular form. Okay, you can see it here also. Okay, upper triangular form. So we can reduce a matrix to row echelon form by applying the suitable row operations, and we can reduce it to column echelon form by applying the column operations or column transformations. You may have different operations to reduce it to echelon form. Okay, thank you.